The following video will concern the WOW signal from the 70s. First, we're going to address the 2017 claim by Antonio Paris, a Florida adjunct professor of astronomy at St. Petersburg College. He was off by 45 minutes or more in more than one way, more than 2 degrees, and he did not provide specific frequency data about his results to be able to compare his idea that comets caused the signal for the WOW signal in the 70s. So it's not a useful point. Now, that doesn't mean that I'm a peer, and this isn't a peer review. He probably looked up the information accurately through an almanac for the likely timings on like a chart for when the comets went through in the same part of the sky. However, it wasn't accurate enough because it would be near it, kind of. Remember, there's degrees, minutes, and seconds. That means 360 degrees in a circle, and then 60 divisions called minutes, and 60 divisions of those called seconds, versus hours, minutes, and seconds, literally used to measure the sky, where you divide the entire circle of the sky, the sphere, by 24 instead of 360 before you use the word minute. In this case, minutes means he was literally off by the timing of 45 minutes for this to be the WOW signal source, being a comet. Now we'll go on to the rest. In Delaware County, Ohio State University Radio Observatory set up a telescope, the Big Ear. It was a 22-year-long project and was based on a bunch of equipment hooked up to a big reflector and a couple of feed horns and other equipment at one time or another. In 1977, August 15th, they had a computer running unattended, monitoring the system that was sampling 50 narrowband channels, 10,000 cycles per second wide, about as wide as an AM radio transmission, out of a half megahertz of bandwidth allotted to it from a specific set of frequencies that started at a specific frequency. Now, when this was going on, they had a crystal oscillator that they were using that was off from the ideal, and it was used, and they compensated for that, and I'm using the compensated numbers. This was, at the time, measuring 50 frequencies, all of them stacked one on the other, and measuring the signal-to-noise ratio. Basically, you look for the background level of noise and declare its minimum value to be 0, and then the maximum noise level that's commonly available, let's say 90% of the time, as a value of 1. And then every other noise signal, you use that information and figure out how many times louder it is than the grass or the noise level, the hiss. Now, this piece of equipment would then take these results by scanning all 50 channels, either all at once, ka-chunk, or in sequence, 10 times each apparently. And every 10 seconds it would have the printer take the information and print it out as one long single bang on the paper, and then move it up a notch. And this meant that it would print out all 50 channels of data at the same time. Now, in order to pack it that tight, they came up with a pretty clever way of doing it. Since the signal ratios or signal intensities aren't just 10 to 1, it would go 0 to 9, and then A would be 10. And it would go from A through Z to give you a total of, let's say, 36 values above the noise, give or take. And it also included, printed out on it, the frequency compensated positioning that it was using based on how the Earth is rotating and moving through time-space to try to get rid of any red or blue shift caused by it, which is measurable. And it would do that by adjusting the frequency ranges of all 50 channels by moving one bias oscillator, the one that we're talking about. Now, when it printed them out as numbers and letters, it could print out 50 channels at once, and it would number them 0001 or 0102, whatever. They have 0102. It would do this, and then it would go across to 50. So it had 0 through 49 and then 50. And all this did was say whether or not they were picking up something. The idea was to detect any signal and then see if it repeated the next night. Or tell everybody, hey, we found this, we saw it, we're not aiming at it tomorrow, you can go check on it. Now, it would do a really clever way to consistently scan the sky and be able to match it up to the clock and the angle. Degrees, minutes, and seconds, like I mentioned, can include hours, minutes, and seconds, and you can just use a clock to declare the position in the sky. You just find out what that fixed point in the sky is based on, line it up with your clock, and then tell it to adjust based on that. The next thing about this is the other part of it is you'd rely on the Earth just rotating on its axis to do a full scan of the sky. Now this used 2 feed horns, and one or the other, or both, I guess, could be turned on and receiving. But the point is, we're assuming one or the other was working. So there's 2 possible pieces of sky that the signal could come from. Now, the letters that were printed out are considered kind of famous. It's 6equj5. Now, what do these values actually mean? A ratio of 6 to 1, 14 to 1, 26 to 1, 30 to 1, 19 to 1, and 5 to 1 over a 72-second period of time, approximately equaling 60-second samples bookended, which would be 70-some-odd seconds. Now, this matched a point source in deep space being swept like this exactly. And they figured out that the curve that it took up, because it kind of trailed off in a weird way, and was kind of lopsided, was 72 seconds of sky that was viewed, with an accuracy of 99% or more curve fit. That's really suspiciously exactly what they were looking for. This one was found on channel 2. Now, this occurred on time basis. The exact center of it, I figured out from a video where it could be, and it wasn't pointing properly at one star or another, but we got one kind of close. It was at 11:16 p.m. and 5 seconds, somewhere thereabouts. The reason it says 11:16 p.m. Eastern Daylight Time is because that's, well, I'll read the numbers to you. The point where you get the peaks happening, start and stop times are well known, but there are other frequencies that are picked up. Again, it picks up 50 frequencies. Channel 2 is the one with the string that's very famous. Channel 7, which is 50,000 cycles a second higher frequency, picked up the following values: 0, 3, 6, 1, 3, 0. Now, that's not a really good curve fit. It's not good, clean, but it's 23% of the intensity at peak. And it has some curve to it, so it kind of looks like the same signal, but weaker. Now, that's not exactly how radio signals are supposed to work, but it is how they work if they're sending or, if they're being used for encoding some data. It can also just be superimposed over noise at the same frequency. That was channel 7. And that one had the peak occur approximately 22:15 timing. That would be 11:15 and 59 seconds, almost exactly 16. So 11:16. The other one was 11:16 and 10 seconds. That's channel 16, and its peak was 17% of the intensity of the WOW signal, and it's 140 kHz up above it. And it had a sequence that is shaped like this: 30, 2, 0, 7, 0 again, 1. This is not a curve fit. This is more of a peak. And remember, the other curve on channel 7 had the peak in the wrong location. Now, this could happen if the 2 sample times that we're sampling and presumed to be in the middle of the sample process were actually sampling a wave that was overlapping them. So we're going to look at this and see what we can do with this to figure out what kind of signal this could be. Now, again, 10 kHz is about a bandwidth of an AM radio transmission, but we're getting signals 50 kHz up and 140 kHz. And again, if anybody's curious, channel 2 was set approximately 50 kHz higher than a magic number frequency in time-space called the hydrogen line. It was actually 49,854 cycles per second higher, not 50,000 flat. It's a different number. It's a very specific frequency. And we can just call it 50 kHz high. Now, the hydrogen line is a protected band of frequencies that can go through interstellar cosmic dust and clouds and go through the Earth's atmosphere, and is very useful for radio astronomy. So radio transmitters are not supposed to send on it. Now we're going to look up what could happen to cause this without breaking that rule. A narrowband transmitter at 1/2 the frequency at like 710 megahertz would produce a much weaker signal, but it would have a noise signal, a beat frequency, at 1.42 gigahertz, which is the range we're dealing with here. If we want to do one that's a third the frequency of 1.42 gigahertz, that would be 473 megahertz and a little bit above. Now that would make it a much weaker version because every time you triple it, you drop it a lot more than you might think. So that would be the only source. But then again, we have this other one that looks like a curve and the other one that looks like a spike. Now, some people have invoked, what if it was an FM stereo signal and it just got multiplied all to hell and gone? Okay, that's kind of possible. Under very limited conditions, a radio transmitter can be made to put out a burst of signals that acts like a square wave and produces odd harmonics. A lot of them. 3, 9, 20, you get the idea. It can produce odd frequency harmonics. So let's look at that. Let's look up frequency modulated radio stations. USA Broadcast has a max range for the frequency of 200 kHz for FM 88 to 108 megahertz. Taking these numbers and multiplying them until you get to 1.42 gigahertz is a bit much, but okay, let's assume something like that. Maybe a transmitter blew up. What would it have to be transmitting? Now, again, we're starting off with a carrier frequency. This is not exactly how FM works, but let's assume somebody built something like this or it blew up or whatever. We start from 0 to 20 kHz approximately for the entire mono FM sound transmission. It's altering the frequency to be in time with the music. It's a continuous intensity. And it has the carrier frequency here, and it's modulating the carrier up and down, but that creates noises and whatever up and down the range. And very importantly, channel 2 on this receiving system that picked up the WOW signal wasn't looking for signals below, 50, 100 kHz below. It wasn't. It was barely looking, another 10 kHz down. So this is a scenario where we could have these kind of beat frequencies happen from an FM signal source. Okay, fine. So we have our carrier frequency that's supposed to be continuous intensity, which is what this looked like when it swept past it because the Earth was rotating on its axis. Okay, that would be a mono FM sound carrier and the pilot signal at 19 kHz. Okay, again, we have 50 kHz up, we got a signal, but not 20. 20 is close enough. We should get some sort of tickling at that detector signal. So that's not likely. What else do we get? Well, we have the differential stereo signal at 54 kHz down to 23 that could cause it, but that would imply that it would also send a pilot signal if it was a stereo broadcast. Those are the only two frequencies that need to have a curve fit, but then again, FM normally doesn't have intensity changes, which would cause, a lot of this artifacting. The other option is, well, let's go to 140 kHz. Why would we get a spike but not a continuous curve pattern? Why would we get a blip, basically, instead of a whoop? Okay, well, at 92 kHz and 60 kHz and wherever, you can have a not a very broad band like 5 kHz, 4 kHz digital signal. So that would accommodate, but that's at 92 kHz higher. So it would have to be some weird version of an FM broadcast where they didn't include the pilot tone to say it was stereo, but was using a stereo encoder type method with an analog signal. Okay. It's much more similar to an AM signal and the other signals that were on the upper sidebands. The other harmonics would very likely just not be there by accident. And I'm going to repeat, 2017, Antonio Paris in Florida came up with an idea that this was caused by a comet. There aren't any comets that line up, and he probably consulted an almanac rather than looking up computer modeling to figure it out more accurately. So he got it off by a little bit. It's less than an hour, but that's still enough to make it not accurate. Next thing is, this doesn't match up with any known signal that I can look up. I'm sure there was some slow scan TV or something like that doing this, but nobody's brought up any examples of it in the many, many decades since then. So again, it wasn't a comet, and the letter pattern is not significant. It's the intensity pattern of 30-to-1 ratio from the noise. Signal to noise ratio of 30-to-1 is pretty damn good for a signal that might have come in from anywhere. Could this have been bounced off of something floating in space? Technically possible. A perfectly round object, like Sputnik sitting out there or something. But that's not likely either. It's still a mystery, and it wasn't solved in 2017 by being comets. Thanks for watching. Have a good day. Good luck.